We look to the stars, hoping to find someone else out there. But what if we've been looking too far and life is hiding much closer than we think? Not in distant galaxies, but right here in our own solar system. Under ice, inside toxic clouds, floating in lakes of methane. If alien life exists, where would it be? What would it look like? Would it swim beneath frozen oceans, crawl through sulfuric skies, or fly on wings we've never imagined? And if it's out there, how close are we to finding it? In this video, we'll explore the 5 most promising places in our solar system where alien life might exist, and the real space mission scientists are launching to find it. From Europa's hidden oceans to the mysterious clouds of Venus. This isn't science fiction. This is science catching up with imagination. So let's begin with the place NASA is betting billions on. If you enjoy this video, please like and subscribe to join us on this cosmic journey. If alien life exists anywhere nearby, this might be the best place to find it. Not Mars, not Titan, but a small icy moon orbiting the giant planet Jupiter, where NASA is spending billions, not to find aliens, but to find out if life is even possible. Europa. To most people, it looks cold and dead. But beneath its frozen surface is something astonishing. A global ocean, not a lake, not a pocket. A deep, salty, planet-wide ocean, buried under 15 to 25 kilometers of solid ice. How do we know it's there? Because of Europa's magnetic field. When NASA's Galileo spacecraft flew past in 1997, it detected electrical currents flowing through something conductive. That something was salt water. And scientists now believe that the ocean could contain more water than all of Earth's oceans combined. But water alone isn't enough for life. It also needs energy. And Europa has that too, thanks to the gravitational pull of Jupiter. The constant flexing and squeezing of Europa's rocky interior creates heat enough, perhaps, to fuel underwater volcanoes or hydrothermal vents. Here on Earth, life thrives in places like that, deep in our oceans, pitch black, using only chemical energy. So the question is no longer, could Europa support life? It's, why wouldn't it? And that's exactly why NASA is going all in. NASA's Europa Clipper, launched on October 14, 2024, is now en route to Jupiter's moon, Europa. This billion-dollar spacecraft is designed to search for signs of alien life beneath the ice. It won't land. Instead, it will fly past Europa dozens of times, scanning its icy shell with radar, spectrometers, and cameras to look for heat, salts, chemistry, and motion beneath the surface. Not to find life directly, but to detect the fingerprints life would leave behind. If anything is swimming beneath that frozen crust, Europa Clipper will be the first to knock on the door. So, if there's one place where alien life might already exist in our solar system, Europa might just be it. But what if life isn't hiding under ice, but spraying right into space? Let's talk about Enceladus. Enceladus was once thought to be just another frozen moon, until it erupted. Just like Europa, Enceladus looks quiet, cold, dead. But appearances can be deceiving. In 2005, NASA's Cassini spacecraft flew past Saturn's tiny icy moon and spotted something erupting. Not gas, not dust, but water. Massive plumes bursting from cracks in the surface, shooting hundreds of kilometers into space. And when Cassini flew right through one of those geysers, it didn't just find water. It found hydrogen, salts, organic molecules, everything life needs. And the ratios of those chemicals? So strange. Some scientists believe the only way to explain them is life. Microbes deep beneath the ice feed off hydrothermal vents just like the ones found at the bottom of Earth's oceans. So what if Enceladus isn't just active? What if it's alive? It rains methane on Titan. Rivers flow with liquid hydrocarbons. There are lakes, dunes, and seasonal storms. And yet, not a drop of water. Titan, Saturn's largest moon, is one of the strangest places we've ever studied, and maybe one of the most important. Because even without water, Titan may hold the answers to one of the biggest questions we've ever asked. How does life begin? Welcome to Titan, a world both alien and familiar. It's bigger than Mercury. It has an atmosphere thicker than Earth's. And it's the only place in the solar system besides Earth where we've found liquid lakes on the surface. But these lakes aren't water. They're made of methane and ethane, hydrocarbons so cold they'd freeze the blood of any Earth-based life. It's utterly alien, and yet strangely familiar. Scientists have found complex organic molecules in Titan's thick orange haze. They believe ultraviolet light is driving chemical reactions that may resemble the early chemistry of life on ancient Earth. That's why Titan is so compelling. It may not host life today, but it could show us how life begins. In July 2028, NASA plans to launch Dragonfly, a $3.35 billion nuclear-powered rotorcraft, aboard a SpaceX Falcon Heavy rocket. After a nearly 6-year journey, Dragonfly will arrive at Titan in 2034. It will land in the equatorial dunes, and then fly, not just once, but again and again, to dozens of locations across the moon's surface. For 3 years, it will study the rocks, the air, and the chemistry, searching for clues about prebiotic molecules, habitability, and whether something or someone ever existed here. Dragonfly isn't just a spacecraft, it's a flying laboratory and a time machine, exploring the ancient past on a world we still barely understand. But Titan isn't the only moon hiding an ocean. There's another, even bigger, wrapped in its own magnetic field, and hiding something deep beneath its icy shell. Let's go to Ganymede. Beneath its icy surface, Ganymede hides a secret. It's not just the largest moon in the solar system, it's even bigger than Mercury. And deep beneath its frozen crust lies an ocean. Not a shallow one, but a global saltwater sea, possibly 100 kilometers deep. That's more water than all of Earth's oceans combined. Ganymede is also the only moon known to have its own magnetic field, a protective bubble that could shield life from radiation. Scientists believe that heat from Ganymede's rocky core, combined with tidal forces from Jupiter, may warm the ocean just enough for life to exist, especially around possible hydrothermal vents. But we've never looked closely. Until now. In 2023, the European Space Agency launched JUICE, the Jupiter Icy Moons Explorer. Its goal? Study 3 of Jupiter's ocean worlds, Callisto, Europa, and especially Ganymede. JUICE will arrive in 2031 and become the first spacecraft to orbit a moon other than our own. It will scan Ganymede's icy surface, probe beneath it with radar, and search for signs of subsurface oceans, magnetic activity, and the conditions that could support life. For the first time, we'll be able to ask, is Ganymede alive beneath the ice? We've searched for life in cold, dark oceans. But what if the next clue to alien life isn't buried in ice, but floating above in clouds of acid? Time to visit Venus. In 2020, a signal appeared from the clouds of Venus 1 that shouldn't exist. Astronomers detected phosphine, a gas that, on Earth is produced by microbial life in oxygen-free environments. This discovery stunned the scientific world. Phosphine should not survive long in Venus's atmosphere, so something or someone must be making it. But Venus is no paradise. Its surface is hot enough to melt lead. Its skies are filled with sulfuric acid, and the pressure is nearly 100 times greater than Earth's, yet about 50 kilometers above the surface. Conditions change. Temperatures drop. Pressures stabilize. It becomes almost Earth-like. And in that strange suspended layer, some scientists believe microbes could survive floating in the clouds. To investigate, MIT and Rocket Lab are launching the Venus Life Finder. Planned for launch no earlier than summer 2026, the mission will send a tiny probe into Venus's atmosphere. Its goal to search for organic molecules using a technique called autofluorescence detection, a way to spot the glow that life-related compounds might emit. It won't confirm life, but it might detect the chemistry that life leaves behind. And in a world we thought was long dead, that would change everything. We've searched for life beneath ice, in methane rain, and in clouds of acid. But maybe the greatest clues aren't here at all. Maybe they're drifting through the light of distant stars. Let's go beyond the solar system. Beyond our solar system, space stretches endlessly, and scattered across that darkness are thousands of planets. Some rocky, some giant. Some are warm enough to hold water, and perhaps some hold life. With telescopes like James Webb, we've started reading the atmospheres of distant worlds. Not with landers, not with rovers, just with light. In the years ahead, new missions will reach farther, search deeper, and ask harder questions. We're no longer just exploring planets. We're exploring the possibility. We've only just begun, and the universe is still waiting to answer.